You see that? That's the sun. And everything you know about it is technically wrong, because by classical physics, the laws we all grew up trusting, the sun shouldn't shine ever. But it does, every second for 4.6 billion years and counting. Why? Because of a cheat code. A cheat code in nature's own operating system, quantum tunneling. Let me show you what that means. Now, stars are categorized based on their luminosity, and about 95% of all the stars in observable universe are either the size of sun or smaller than that. Means that their surface temperature is around 5500 degrees Kelvin or less than that. And that's important because at the cores of these kind of stars, like our sun, there is incredible temperature and incredible pressure. And the core of the star is incredibly dense, like it's 150 times more dense than water. And at these extreme conditions at sun core, which has tons and tons of hydrogen atom, those hydrogen atom loses electrons and just becomes bare protons. And those protons fly, and they fly around at incredible speed. And you would think that that should be enough for two protons to bounce on each other and fuse and become helium, right? Well, not really. Here's the problem. Every proton is positively charged. That means that, like the magnets of same pole, they repel, and they repel violently. Now this resistance is called as Coulomb barrier, and it takes a lot of energy to get past it. How much? About 1 million electron volt. And how much energy does these protons have? 100 times less than that, 0.01 million electron volt. So by all logic, the fusion shouldn't happen, the sun shouldn't shine. Now, as per classical physics, since there is no fusion, there should not be any light released, no energy released. The sun should have fizzled out even before it began. In fact, it may sound weird today, but before quantum mechanics came along, sun was thought to be powered by chemical combustion like fire. But that could last only 1000 years, and something didn't add up. So what did we miss? In classical physics, particles are thought to be solid points. But in quantum worlds, particles aren't solid points. They are the waves of probability, a cloud where they might be. And this is called a wave function. Now here's the weird part. That wave doesn't stop at a barrier. It spills over into a forbidden zone, the area where it shouldn't be. And sometimes the part of that wave goes through. Even though the proton doesn't have enough energy to climb the Coulomb hill, it can tunnel through it. No extra energy, no shortcuts, just probability. Now once two proton tunnels close enough, the strong nuclear force takes over, and it's 100 times stronger than the repulsion force. They snap together and they fuse together, making deuterium. The positron and neutron shoot off, and a gamma radiation is released. That's light. That's heat. And that's what we see as sunlight. It's fusion powered by quantum cheating. Now, not all protons in sun core have same energy. Some of them are faster, and the faster they are, higher chances of them to go over the Coulomb hill and fuse together. Now, this sweet spot where speed and tunneling overlap is called as Gamow peak. Even though only a tiny fraction of protons make it through, there are so many collisions happening every second that it's enough to keep sun shining. Now, every tree, every breath, every beat of your heart happens because once in a while a proton does something it is not supposed to do. It slips through that barrier. Without quantum tunneling, there would be no fusion, no light, no life. The sun shines not because it follows the rule, but because it bends them. And if our star, the thing we all take for granted, is running on a loophole in physics, what else might be? So, if you like these kind of videos, do subscribe, and I'll see you next time around. Bye bye.